Game theory has given us a wide variety of ways to think about collective action problems, or how do we get independent actors to work together towards a common goal. They give them all kinds of fun names like Prisoner's Dilemma, Stag Hunt, Tipping Games, but right now we're just going to talk about coordination games, the one that we're actually using in class. The purpose of this video is to explain to you how to read a table like this, as was available in our Sing reading. The first thing that you need to understand is that the rows and columns combined indicate the players. In this case, the rows represent anti-government actors, and the columns represent pro-government actors. Each individual row or column represents a strategy that those actors can take. So, the top row represents the anti-government actor strategy of rebelling, whereas the bottom row represents what would happen if they defend or stay loyal to the government. Similarly, this column represents what happens if pro-government forces rebel, if they actually defect from the government. And the right-hand column represents what happens if pro-government forces continue to defend their government. The numbers represent the payoffs to all of the actors. A payoff is a symbolic representation of what they would actually get out of it. Would it be good for them, bad for them? What do they actually get? The first number out of the number pair represents the payoff to whoever's on the row. So in this case, the 9 is the payoff to anti-government forces if they rebel. The number on the right is the payoff to the actor in the column. So here, the 1 is the payoff to the pro-government forces if they rebel. Again, these numbers are really meant symbolically. There's no like, oh, pro-government actor, here, you get 1, rebel, you get 9. They're meant to convey relative preferences and relative wins and losses. So what you do to read this table is compare the payoffs for each player. Here, I've circled the payoffs to anti-government forces. Again, the first number in the number pair. And you can see here, 9 is bigger than 1, is bigger than -5, which is bigger than -9. What this means is that you can rank or tell what the preferences or outcomes for the anti-government forces would be. Anti-government forces get the most, the 9, the highest number, when they rebel, but only when the pro-government actors join them, when they also rebel. So this box represents the best choice, the best outcome for anti-government actors. The second best outcome for anti-government actors is here represented by the 1, the second highest number. They get the second best outcome if anti-government forces actually remain loyal to the government they defend, when the pro-government forces also defend. Anti-government actors get an even worse outcome when they rebel against the government, but the pro-government forces defend the government. In other words, when there's a clash. I did not include the fourth option here because it doesn't really make sense to have anti-government forces defending the government and pro-government forces rebelling against it. But what you need to think about here, again, is the relative ranking of the best outcomes for each player. Note both the ranking and that they depend on the actions of the other player. We do the exact same thing for the columns, for the pro-government forces. Here, the 9, the highest possible outcome for pro-government forces is when both pro-government forces and anti-government forces remain loyal. This makes sense. The government still stands. The next best outcome for them is when the anti-government forces choose to rebel, and then the pro-government forces rebel as well. They defect. A worse outcome for the pro-government forces is the same as it is for the anti-government forces. They both are seeking to avoid conflict because there'll be loss of life. This is what they call in game theory a dual equilibrium solution, where there are two possible outcomes that benefit the players, where where anti-government forces rebel and pro-government forces rebel, or when anti-government forces stay loyal and pro-government forces stay loyal. There's no real way to judge between these two just from the game itself. Who wins, which outcome actually happens, gets chosen, depends on the individual actors in real life. And that's something that I wanted to highlight for you about these types of games and these types of tables that represent them. We don't get an outcome where, if they stick together, that's the best possible solution, no matter whether they rebel or defend. We don't get that because that's what the table tells us. The author created this table to serve as a metaphor and explanation visually for how that actually happens. These sets of preferences for pro and anti-government actors were set up the way they are specifically to deliver this outcome and just to demonstrate that this is one way you can look at this very complicated problem. I hope this helps you understand some of the charts that you'll see in the readings that we do moving forward.